problem 1b, again we're testing for convergence or divergence. And our series is n equals 1 to infinity n squared tan 1 over n squared. Alright, so at the onset of this problem, this might look a little difficult because you don't really have anything to compare this to by comparison tests, or at least not something that's immediately obvious. And you can't really use any of your other tests here because this would be a really difficult integral. Ratio test is not going to give you anything because you don't have any exponents or factorials, and it's not alternating. So we're going to run out of options here pretty soon. This is actually something that you need to rearrange, and I put this on here because this is a really common type of problem requiring you to remember trig limit identities from a long time ago. So the first thing you want to do is recognize that you have 1 over n squared in tangent. If you could get 1 over n squared somewhere else in the problem, you're going to be able to work out some identity. You have n squared here, but if you put that in the denominator instead, it would become 1 over n squared. So this is the exact same thing, except now this is written in such a way that we can use our limit identities. So recall that tangent of theta over theta as theta goes to 0 is equal to 1. That's a limit identity that you probably had in Calc 1. Same thing with sine theta over theta, tan theta over theta. So we have exactly that, where the theta is 1 over n squared. So the only thing we need to be sure of is that that quantity is going to 0. Now n is going to infinity, which means 1 over n squared is going to 0 because we have 1 over infinity. So this is really like tangent of 0 over 0, which is exactly what this says. So the limit of our summand is 1. So that immediately tells us that this series is divergent by test for divergence. Remember that the limit of your summand always has to be 0 if your series has a chance of converging. If it's not 0, it automatically diverges by test for divergence. So this is a divergent series just by test for divergence. So you actually didn't have to do any of the other tests about limits, comparison test, limit comparison test, any of those other ones. Those all would have been really difficult to do in this problem. Instead, recognizing your trig limit identities and just rearranging and showing that your limit of your summand isn't 0 in the first place automatically diverges by test for divergence.